quick sketch of this. X could be up to 2, back to -2. Pretend those are straight lines. And there's R. You've got the point 2, 3 up here, -2, 3, 2, -3, etc. So, since we want to find the max and min on the boundary and the interior, are there any critical points on the interior? So first, let's hunt for critical points. Then as I hunt for critical points, I take my gradient. I get 2x plus 4. And I get 2y plus 6, if I did that right. Those are the right partial parameters? So we see the gradient always exists. We don't have to worry about the weird case. The gradient is equal to the 0 vector, x equals, and y equals. And so -2, -3, this corner is the only critical point. It's not on the interior, so it will be taken care of when we do the boundary. So we don't have to worry about the interior point. There are no critical points on the interior. Now, do you want to do the method of Lagrange on this? Yeah. Okay. Well, actually, we'll do a little of both. So the method of Lagrange. We have the gradient for f, so that's done. Right? But on the boundary, we have to break this into 4 different pieces because they all have different gradients. And there is no one function that's going to define that nicely. So, if you have this vertical line where x equals 2, the gradient for that is either, what's the vector perpendicular normal to that in the plane? Perpendicular. What's the vector perpendicular to that line? I said here. You saw. That's inside the vector. I want a vector. J? Let's see. J would be pointing up in the y-axis. So J wouldn't be perpendicular to that. It would be parallel to that. I. Okay. So I. And or 1, 0 if you prefer. What's that? Did you see this line? Find me a vector perpendicular to that line. Because the gradient, that's the role the gradient does in Lagrange. And so, okay, here's another way to do it. What's the equation for this line? X equals 2. Right? So g of xy equals x. Back here ways. The function is always equal to the expression without the number. Because if g of xy equals x, then our boundary is g of xy equals 2, a level curve. And what's the gradient for g? What's the gradient for g? 1, comma, there you go. But because it's a line, you just look at it and find perpendicular. Because we're doing this piece first. We're doing the boundary. And because it's a rectangle, you've got to do each line segment separately. Now, So there's a gradient of G. We've got the gradient of F. So we know that 2x plus 4, comma, 2y plus 6 is equal to lambda times 1, 0. So 2x plus 4 equals lambda. 2y plus 6 equals 0. Is that right? Question?
How do you get the gradient of G, 1, 0?
Here's G.
Oh, okay.
Is that okay?
Yeah.
And so this tells me y equals negative 3. And, I'm sorry? X equals 2 is our constraint. So 2, negative 3 is the only place where the gradients are parallel. And so this point down here is a candidate for max or min. How would that be different? Let me get here. Yeah, no black. Okay. If we're up here. Up there, the equation is y equals 3. So across the top, if y equals 3, I would let g of x, y equal y. And the gradient of g is 0, 1. And is the vector 0, 1 orthogonal to this? Yeah. And the gradient for f is still the same. 2x plus 4, 2y plus 6 equals lambda times 0, 1. So 2x plus 4 equals 0, and 2y plus 6 equals lambda. And y equals 3. There's your three equations in x, y, and lambda. So what is x? And y has to be 3. So you're at negative 2, 3. So it looks like this point is the only candidate there. Okay, then you could continue around, and you would see that on this thing, fx is going to happen fast, right? You done copying there? What's that? We found 2 points, on one point on this edge and 1 point on that edge. Now what happens when we come down and we look at the line over here where x is negative 2? Well, here, watch. X is negative 2. G of x, y is still x. Now it's that level curve. Does it change the gradient? Does it change any of this? So you would get the point negative 2, negative 3. And then if you did the bottom, that would just be coming down here saying y is negative 3. You have the same g. You have the same gradient. Everything would be the same, only x is negative 2 and y is negative 3, and so you get those 3 points. Plug them into your f, and they would tell you what the biggest and smallest value are. What was my f? I lost it. Oh, x squared plus y squared, etc. So, to finish the problem off, you'd have to take all your candidates, and that's going to be, what, 4 plus 9 minus